So we discuss about the confidentiality. Now there is another method applied to the email that is called as authentication. For example, if you want to say that the email that is sent it by a legitimate user or not, so then we need to authenticate that email. So we will ensure that the email has been sent it from the legitimate user. So to ensure that, we apply the method of authentication to the email, and then we apply the integrity to the message, integrity to the we ensure the integrity of the email. Integrity means we want to ensure that the email has not been modified, or email has not been changed by the intruder or the attacker. So in order to do that, we apply the different integrity mechanisms, different integrity methods, message integrity methods to the email, so that the intruder cannot change the data, or cannot change the email. And then we have uh, a non-repudiation of uh, the email. For example, sometimes it also happens that when we want to send the email, their message comes, so you cannot send. Or for example, we not cannot access particular email. So this comes in the non-repudiation feature. So that is a denial of service feature. So we want to protect the email uh, to rather, for example, if there is an intruder or an attacker in between the sender and the receiver, he may uh, he may he may retain the email from sending. So we detect that intruder, and then we try to send the email. So in this way, we can secure the email through different means. So these are the different methods which are applied to secure the email. So we will discuss different standards and different algorithms which are applied to secure the email. Like for example, there's an algorithm that is used to secure the email, that is called as a pretty good privacy standard. So that is actually that is a de facto standard for the email security. Means that is a by default standard that was developed by Phil Zimmerman, and it uses different algorithms. So we will discuss what algorithm the PGP, or pretty good privacy standard, uses, and it can be used on the Linux, on PC, or Macintosh, and other Windows system. And previously it was freely available. Now it is also having the commercial version as well. And what are the how we can obtain these different security method, or different security procedures which we have discussed, like for example, confidentiality, authentication, integrity, and non-repudiation. So for example, if we want to obtain the authentication for the email security, for the email, then how we can do that? So we can have number of steps over here, as you can see on the slides as well. For example, first we create a message, and then we apply a hash function, that is a sh1 function, to generate the hash code of 160 bit. And then this hash code would be attached with the message, and then we encrypt the message using a private key, and then we attach that hash code to the message. So at the receiver end, the receiver decrypts that message with a public key, and then again he creates a hash code from the message, and regenerates the hash code, and then that hash code is compared with the original message hash code. If it is a same, that means the message has not modified, or the message has been coming from authenticated user. So in this way, we can ensure authentication of the message, and then after that we have other feature like how we can maintain the confidentiality of the email. So for ensuring the confidentiality, there are also a number of steps which are used by the PGP standard. Like for example, if you want to send the message or send the email, so the email that which is generated or email which is sent, and then we generate 128-bit session key, and after that we encrypt the message with the key or with this session key, and then we send the data to other system using a RSA algorithm, and then we attach the encrypted message using an RSA algorithm, and then we send to the receiver. And when the receiver receives that, so it uses a RSA algorithm and decrypts the private message with a private key, and then after decrypting the message, it recovers the session key. And using this session key, we will decrypt the message. Now you can see that uh, there's the session key uh, which is actually used here to decrypt the message, and that is actually send it to the from the sender to the receiver through a secure method using an RSA algorithm. And because this key is hidden from the attacker, so he cannot decrypt the message, and so he require a proper key to decrypt the message. So that key is only received by the receiver, and he decrypts the message, and he can only be able to decrypt the message from that key. So that is why in this way the PGP provides the confidentiality to the data. So in this way, the intruder cannot get the information or disclose the email without the proper key. And then we can use both the methods, uh, uh, confidentiality as well as authentication. Like for example, in this way we create a signature, and then we attach that to the message, and then as we have discussed, we can create signature using a private key or some code. So we have discussed that, and that that is attached with the message, and then we encrypt both message as well as the signature, and then we attach the session key to the message using an RSA algorithm, and then at the receiver end, the private key would be used to uh, decrypt the message or decrypt the session key, and then with the session key we can decrypt the message as well. So in this way, we can use a confidentiality, or we use authentication, or we can use both confidentiality as well as the authentication to the data. And then the PGP algorithm also have some other features. Do you have any question up to now? Do you have any question up to now?
No, sir.
No, sir.
Okay, so we discuss about authentication and confidentiality, that how the PGP standard can provide authentication and the confidentiality. Now we discuss other feature of the PGP standard. For example, if he wants to send the data to other system, it may be required to send the data using a method that is called the compression method, and it uses a compression method to compress the data, and then it may be encrypted, and then received by the receiver, and the receiver decrypt that message, and then uncompressed by the PGP standard. So he may use different algorithms, like for example, zip compression algorithm, or some other types of algorithms to compress the data and to decompress the data. So, so the data which is email, which is sent it works like that. It may be compressed and then may not be compressed, and then it is encrypted using encryption method or encryption algorithm, and it may use a RSA algorithm to send the message to the receiver, and it uses a session key for encryption, and at the receiver end, the receiver decrypts the message with the private key, and then decrypts gets a session key from the message, and then this session key will be used to decrypt the message. So in this way, as we have discussed that particular session key is used here to decrypt the data, and that is sent it from the sender to the receiver, and that is sent it in the encrypted form. So in this way, the intruder or the attacker is not able to get that key. So that's why it makes the email secure, and the receiver is only able to get that key and decrypts the message and gets the information from that. And there are some other compatibility uh, issues with the PGP standard, that may be, for example, it may use the message which must be encoded in a proper coding scheme, for example, ASCII code or some other code, and then at the receiver end, the receiver should support that particular code in which the coding scheme is applied by the sender. So in this way, there should be compatibility between the sender and the receiver. Whatever the coding scheme is applied by the sender, the receiver should also support that coding scheme. So in this way, it can uh, match the coding scheme. Or for example, if it uses a Redis 64 algorithm, so receiver should also support that algorithm. So this algorithm applies also error checking method like cyclic redundancy checking method to the method, and then at the receiver end, uh, if any error is in the data, for example, it can be detected by that algorithm as well. So the thing is that we require to make the code use the code which is compatible both at the sender end, both at the receiver end, or with the PGP standard that we are using to send the data from sender to receiver. Or for example, this can be further explained by this figure. Like there's a, for example, there's a file, we represent it as a X, for example. It applies a digital signature to that, or the email, for example, uh, it, it generates from the digital signature from the message, then it attaches that digital signature to the message, and then it compresses the data. Then after compressing the data, it applies encryption to the data using, for example, if there's a RSA algorithm is used, so we will encrypt the data with the public key, for example. Then it will also encrypt the data, encrypt the session key as well. So then at the receiver end, we will use a private key to decrypt the data, and then we get the session key. And after getting the session key will be used to decrypt the message as well. So in the same way, we can also apply some other algorithms like Redix 64. So we convert data into Redix 64 algorithm, and then at the receiver end, we apply same algorithm to convert that into the from Redix 64 to the original message, for example. Then we apply the decompression over here, using, for example, a private key to decompress the message. And when we decompress the message, we get the session key from that. And after getting the session key, we can decrypt the message as well. And then if it is compressed at the center end, then we decompress the data using some decompression algorithm. Like for example, we have discussed zip algorithm can be used for the encryption as well as for the decryption. And then we uh, verify the data using a signature, or for example the private key that is used uh, to encrypt the data. So in this way we can apply different security procedures or security functions to the message in order to secure the PGP standard. So these are the different methods we apply. And then we have for example, we are using a session key here. So that could be of a different size. For example, it could be, if it is using a DES algorithm, it could be of 56-bit. If it using a CAST algorithm, it could be of 128-bit, 8-bit or ID algorithm, or 3DS algorithm. It can use a 168-bit uh, uh, key size. Or for example, it can be used by it can follow some standard like NZX 12.17. So in this way, the session could be of different size. That depends on which algorithm uh, uh, is applying a particular key. As we know that we have also discussed that larger the key size make the algorithm more secure, because in this way the intruder or the attacker needs more searching procedures or techniques or processes, or for example brute force search uh, to to uh, to search for the particular or to search for the exact key. So that's why it depends on the size of the key as well. So we also need to select a particular size for the key, so that uh, we make the algorithm more secure. And then we have uh, other uh, keys all are also used by the PGP standard, because it is actually for sending the data, it is using the RSA algorithm, or further encryption and decryption, it uses a session key. So the here the encryption that is applied, that is a asymmetric encryption, because it uses the public key for the encryption from the sender end, and it uses a private key for decryption at the receiver end. So and then it can use further a session key to encrypt the message and to decrypt the message. For example, it works like that. There's a message and there's a session key, and then it encrypts that with the public key, for example, at the sender end, and at the receiver end, it decrypts the message with the private key, and then it gets the session key as well. So that session key will be used to decrypt the message which is received by the receiver. So in this way, we can make the data more secure as compared, for example, if we apply either if only apply ISO algorithm or only apply symmetric encryption. So in this way, we are sending the data through RSA algorithm, and we are encrypting and decrypting the data through a private key, for example, here that is called a session key. So in this way, the PGP standard provides the security to the data, provides the confidentiality, integrity, and authentication to the data. So these are the different methods which can be applied to ensure the security of the data. And then their PGP standard is actually using a pair of keys. For example, there's a pair of public key that is in the form of a ring, for example, here, or there's a pair of a private key can be is used that is in the form of ring as well. So when we discuss the how the creation of the public key and the creation of private key. So actually here the PGP standard uses a ring of public key or a ring of private key, because there could be different messages are sent in, or different emails are sent in from sender to receiver. So he creates a particular ID for an email, and a particular key for ring of key for the email. Then it select a particular key for the email. Then it the message with that key, and then at the receiver end it uses a private key to decrypt the message, and then it gets the session key from that, and then it decrypts the message through that key. So in this way the PGP standard works and uses the keys for the encryption and uses a key for keys for the decryption. And then we have different other methods, like for example PGP key management. So how the PGP manages different keys. It manages different keys through different methods. So, for example, it uses a certification authority. As we have discussed that, for example, in order to ensure that the particular key, for example, is coming from legitimate user or legitimate authority, the certification authority may send public key to different users to encrypt the data, and then at the receiver end, the receiver gets that message and decrypts the message, and of using a private key. So in this way, the certification authority is a key authority here to ensure the privacy of particular key. So if the particular key is coming from certification authority, particular certification authority, that means it is coming from a legitimate authority, then the receiver can press that key and then can encrypt the data and decrypt the data. So in this way, we can apply different methods using PGP standard. If you have any question, then up to now, then you can ask. So do you have any question?
No, sir.
No, sir.
पीजीबी
No,
रिंग
sir.
समझ में नहीं आया सर।
अरे काशिफ मामा
ये पीजीबी रिंग समझ में नहीं आया सर।
Yes.
सर पीजीबी रिंग समझ में नहीं आया।
It is actually the pair of keys which are used by the sender or by the PGP standard. So actually, whenever it sends an email to other user, for example, the receiver, so it uses a key, or it selects a key from pair of keys, and then encrypt the data from that, and then sends the data to the receiver, and then receiver receives that, and then it will also select a particular key from the ring of the private key, and then it will decrypt the message. And in this way, there are the different pairs are used for the sender, for the private key, as well as the public key. So that pair of
सर
keys
इसका कोई
or
सर
ring of
एग्जांपल
keys,
होगा सर?
we can as we have, for example, if there is a single key for sending the data, and if there is a single key for receiving the data. For example, if the same key is used for other emails also, so intruder may be, or a taker may get that key, get that key, and then it can encrypt that email, another email with the same key. So in this way, the intruder can masquerade also. So in order to protect the data for masquerading, so it is important step is taken here that it uses a pair of different keys, and then the user selects a particular key from a pair of key, and then encrypts the message with that, and then at the receiver end it decrypts the message. So it is it gives an advantage that for every message or for every email, the user is able to select a key from the available keys, and then it sends a message to the receiver. So in this way, the email will be secure. So the attacker will not be able, if, for example, if he has got a key of the previous email, then another email is sent it with a different key. So that means the message is still protected. So in this way, we can protect the emails from the intruder or from the attacker, so that we cannot get the actual key which is used to send the data, or which is used to send the email from the sender to the receiver. Okay.
और सर ये मैनेजमेंट की सर इसमें भी थोड़ा सर कोई एग्जांपल देके जरा समझा दो.
So in this way, the different, because as I told you that different keys are used here. So we are going to the user is going to select a particular key from these different keys. So if there's a single key, then it can get that key and encrypt the data, and the receiver receives the data and then decrypt the message. So there are different pairs of the keys are used, so that every message is having a different, and every message every message has a, so this is a way of managing different keys. So in this way we can say that it's a in this way we are managing different keys, so that they are the different keys, a different pair of the keys are used, and the receiver receives that, and it also selects a particular key from a pair of key or ring of key, and then it decrypts the data. So in this way, because there are many keys are used here, and we are going to select a particular key from that pair of key or ring of key, and we are encrypting the message and decrypting the message. So this is actually that method is actually called the managing of different key. Okay.
Okay, sir.
Is there any question?
No, sir.
जी बिलाल ॿुधायो छा
Okay, so then we are using another standard here, or the algorithm here, that is called as S-MIME algorithm. That is stand for Secure Multi-Purpose Internet Mail Extension. So that MIME or S-MIME standard that is used to secure the email, and that applies different security methods, like as we discussed, confidentiality, authentication, and integrity, and non-repudiation. So it is used by many different softwares, like email softwares like Outlook and Netscape, and some other email software which are used to send the email from sender to the receiver. So what are the actually the functions which are used with this with the S-MIME protocol, or with the S-MIME standard? So there are the different functions are used, different functions are given by the S-MIME protocol or standard. Like for example, it is used to envelop the data. So whenever we are sending the data, it's a better way to envelop the data and envelop some message in the paper, for example, into the envelope, and send to the receiver. So in the same way, the S-MIME protocol is used, or S-MIME standard is used here to envelop the message, and then means it covered the message, and then in this way it's a way of securing the message. So in this way, without without uncovering that envelope, the intruder cannot get the message. So in this way, this is the first step that is applied to secure the content. And what is actually done here? So it is actually how the data is enveloped. So it is using actually the encryption to the data, and it encrypts the data, and it attached uh, the the key with the data. And like for example, it encrypts with the public key, and it attached with the session key to the data. And then that envelope data is received by the receiver, and then it decrypts that envelope with a private key, for example, and then it gets a session key to further decrypt the message. And then further for authentication, it uses for example a message digest, or for example encode the message. For example, as we have discussed, that it may use a hash code, or it may use a private key to further sign the data, so that at the receiver end, the receiver authenticates that the particular message or the particular email has been coming from a legitimate user, or the actual user. So in this way, we can envelop the data, or we can sign the data at the receiver end. It again clear the sign, and then it again decrypt the message. So that decrypting of the message is also called unenveloping the data. And then it using that particular private key, it can also hash code. It can also authenticate that particular data has been coming from a legitimate user. So in this way, the SMIME function, or SMIME algorithm, is used to encrypt the emails from the sender and the receiver, and that is used by different emailing softwares, like for example Outlook and Netscape and some other softwares. Like we further discuss that which algorithms are used by the SMIME algorithm, like for example uh, SHA1 and D5 for hash function, and for digital signature it uses a DSS algorithm and RSA algorithm, and for session key it may use AlGamel or RSA algorithm, and for message encryption it may use a 3DS or RC240, or some maybe using a RSA algorithm for message encryption. So these are the different algorithms which are used by the SMIME algorithm in order to encrypt the message, and in order to decrypt the message. And then we have some other standards, like for example, as we know that there's a digital certificates are used to digitally sign the particular data by the authentication authority. So it is a way of authenticating a particular message or particular data by a user. So a user sends some gets a particular certificate from a certification authority, and that attaches certificate with the message, and then at the receiver end, the receiver receives that. If it contains the legitimate certificate or legitimate signature of the data, then it is verified that the data has been coming from actual user or legitimate user. So in this way, different certificates are used, like for example, SMIME